I think we'll start.
Okay.
Because, yeah. Okay. So I'm Bernhard. I'm your MC today. For those of you who were around last week, we changed the format a little bit, and we are going to start with the updates, then some demos, question and answers, and then at the end today we have a lecture by Mike about Marine, the WebAssembly IT runtime, which is going to be super cool for those of you who want to stick around, which I hope everybody does. Due to some time constraints and scheduling conflicts, instead of the updates, we're actually going to start with the demo. We have, starting with Boom, who won one of the most recent hackathons, and looking forward to it. Take it away, man.
Okay. Can you see my screen?
Yes.
Okay. Hi guys. My name is Boom, and thank you for letting us join this community call. Today we are going to talk about the identity link service, and sorry. Okay. And what is the identity link service? This service helps users to associate their social accounts to the DID. And how does it work? The identity linking flow can be divided into two subflows. The first one is that identity linking request, and the second one is identity linking verification. And there will be three components in this service. The left-hand side is the browser application, and the right-hand side at the top, the identity link service, and the last one is the third-party service. This is GitHub, and the flow will start with the browser send the request to the identity link service, which contain the DID and GitHub username. And after the service get the payload, they will generate a challenge code and store the DID and GitHub in the cache. After the user get back the response, they will have to go to the GitHub and create a public disk, which have to contain the DID. After they get back the result from the GitHub, they can continue to the second flow, which is the identity linking verification. They start with sending a JWS, which contain the Git URL and the challenge code in the previous step. And after the server get the JWS, it can verify that the JWS is signed from the user. And after it verify that the JWS is signed from the user, it will verify the Git URL by requesting to the GitHub and check that the content of the Git contains the DID. After it verify the DID from the GitHub, it will issue back the verifiable credential to the user. And let's talk about the implementation of the service. At first, we implement it in Wasm and run it in a public node of the Fluence, but there was a problem. At that time, we don't know how to securely store our credentials, for example, API key. So we decided to run it in our dedicated node. And we instead write it with Node.js with Fluence SDK and connect it to the real node. In this way, we can store our credentials in our node securely. and the web application can connect it via the relay node with the service ID, peer ID, and relay ID. But there was another problem. If we run it in our dedicated node and the service is down or is restarted, the service ID, peer ID, and relay ID can be changed, and the browser application have no way to find a new one. So we have to create a new component. We call it the router, and the main responsibility of the router is to keep the data from the identity link service. For example, the service ID after it is restarted, the peer ID, and we let the web application connect to the router and let the router route the request to the destination service. Yeah, and this is our basic architecture, and all of the requests is written in Aqua, and all of the components is connected by peer-to-peer. Yeah, and let's go to the demo, Tian view demo.
Hi, my name is Tian. I will show you the demo of identity link service. First, I will start with connect to the wallet. We use the ID pointer from TID connect. And as you can see, after I connect to the wallet, I will show my social account. And I'm going to link my GitHub account to the ID. First step, I have to put username of GitHub account. And then I click copy. It will copy the ID. And I have to create gist that will contain my ID. After that, I can go back and continue. The last step, I will click verify to verifying the ownership of my GitHub account. And that's it. Thank you.
Okay, cool, very cool. Thank you. So I got a question. That service you used as for a router.
Yes.
How do you persist the data there? Can you show us that, how you did that?
Sorry, can you repeat it?
How do you store the data on that service?
We store it in the SQLite.
Okay.
Yeah.
Have you looked at the Aqua DHT solution instead of a service?
No, we haven't looked at it.
Okay, so Aqua DHT is basically a distributed key value store, and you may want to look at it. I don't know what. Let me backtrack. What are your plans? Are you planning on doing anything else with it, or was it just for the hackathon? And or do you see future use cases for that?
We just for now we just want to do the hackathon because we see it interesting, and we just want to try it.
Okay, so overall, do you think it's like a good solution or a better solution than some of the other ways of implementing DID, or what are you thinking now that you've done it? Just sort of interested.
Sorry. I'm not sure about the question. Can
you repeat the question, Bernard?
Yeah. now that you've implemented the DID solution with Fluence, how do you see this? Is this like a better way of doing it, a worse way of doing it? Is there a special use case for it? Like, what are the benefits of doing it the way you did it?
Actually, in this way, after we try the Fluence, the Aqua, we saw that it saved the request. I mean, because it peer-to-peer connection, it can call directly to the node without going to the intermediate. And it's great that we can do that easily. I mean, the peer-to-peer communication. But after we tried out, we realized that the communication from the service to the Node.js in our service, it cannot support the promise. So we have to change the way we implement it from synchronous to asynchronous. We have to call it to the destination service, and the destination service has to call it back to the caller. That's the problem that we faced.
Yeah, I remember. I think, Pavel, I think that's fixed, right?
Sorry, my mic was away from me. Yeah, as far as I know, you should try updating the library versions.
Okay, cool.
Okay.
Anybody else have any questions for the team?
I want to just say that the demo looked amazing. So I like the demo, really great.
Yeah, I liked it as well. Sorry, hi, it's you. Could you post, I saw that you had a link to the GitHub with the code in the presentation. Could you post it in the chat?
Yes, I
Then
will.
I can have a look. That would be great. And Bernard, what you said about the Aqua DHT, to use that as to like have like sort of find out what service ID, for example, that is used, so that that key value store is available to everyone. You know, you can't put security on that.
Right.
Is that true? So if you want to store something that is secure, you have to find a different way to do it.
That's correct. Like you could encrypt it, for example.
Yeah, but otherwise it would have solved all my problems. Thank you.
Okay. Is very cool. Thank you. It was a great project. I very much enjoyed it when you submitted it, so it was awesome. And it was one of the more fun ones to look through. It was great. Is Henry here? Henry once, Henry twice. No Henry. All right. Well, then we'll go to the updates. And how about you, Dmitry? Do you want to take that away?
Why not? Hi, folks. Can you hear me? Nice. So this week we have a lot of updates in different areas. Most of them are on the updates channel on the Telegram that we try to maintain as good as we can. So first of all, we have the new version of Aqua released 0.4.1 with the new syntax edition of closures. So now you can create anonymous functions within functions. They capture service resolution and data. So you can take a look on the changelog, and it's reflected in Aqua book in the dedicated page. So that was the first one. And besides this new syntax, it contains a lot, I mean, really a lot of bug fixes. So I suppose that you want to give it a try. Then we switch it to a synchronous virtual machine in the network that's running now, and that's public. Previously, parallelism was actually parallel in Aqua only if you moved execution on different peers, but currently it's parallel within a single peer as well, like both in JavaScript and in Rust nodes. And it gives us some new capabilities. Like, for example, now you can express timeouts on the node. You can say, please try to do this. And if you don't have a response in this time, please try to do that. Previously, it wasn't possible. So it's quite nice. And also, there was a release of Fluence.js. We are trying to improve developer experience regarding error management and reporting, as previously Fluence.js was swallowing some of important errors, and now it tries to tell as much as it could about like error parsing problems, or whether it's possible or not to send the particle to the network, and so on. So it should improve developer experience, especially for TypeScript and JavaScript developers. So that's probably it, what we have done this week, and we have some more features preparing for the following days. I hope that we will fix the last big issue that you found, by the way, with the stream usage inside folds and inside functions, which were not cleaned, and that's a very like strange behavior that you couldn't expect. Hopefully, we will fix it tomorrow. Working hard on that. That's all about updates.
Okay, any questions? So we can give answers.
If I remember, was my question with the streams. Was that related to that I couldn't do anything within a loop? Was it related to that?
Yes. I can explain it in more detail if you want. So there's a pattern promoted in Aqua book to use streams to build values to be used later. So, for example, there is a conditional return pattern when you create a stream, do if else to write into the stream, and then return a value of the stream like as a scalar. So you don't expect it to be used as a stream again. And it's a nice pattern, but actually further in the code, it uses the same stream. To fix this, we introduced it, not yet released, but we introduced the new error instruction that's called restriction in PyCalculus, and it's looks like new something, and then the scope, and it restricts the usage of some name like a stream or a scalar within this scope. Yeah. It will mean that on every loop, if you put this restriction operator, it will clean the stream for every loop or for every function call, and you will be you will be safe. It will require no change in Aqua code, just the error output will be different, and this bug will go away.
Sounds wonderful. I think it was that I tried to start off programming. I wanted to make like an array of objects of things that I wanted to do, and then loop through them, and then I run into problems. So then in the meantime, I just have to write everything out. But now you can do, when this is fixed, probably I can try again to do things in loops, basically, if that makes sense. Sorry.
And by the way, we just realized that we fixed all the critical topology-related bugs in Aqua, so it should be like much more stable than ever before. So 0.4, 0.1 is a big stability release. It's not just a new syntax, which was just also requested by the people who use Aqua extensively to develop big systems. And it's a part of our effort to improve composability and reusability of the code. Just the first, like not the first, but a big step towards what should be like Aqua 1.0.
All right. Any more questions for the tech team? Okay. Any more updates? Anna, Tom, Evgeny, you want to share?
We have hackathon starting tomorrow.
Yes.
And the workshop. So if anybody is interested, there is a Web3 Jam hackathon by East Global and Protocol Labs, and we're supporting it as well with our 2 bounties. I can send the link here in the chat, so you can still apply by tomorrow, or even today. Today is the last day. So please apply, and tomorrow we have Bernard will do the workshop. Yeah.
Nothing, no updates on my end.
All right. All right. Well, in that case.
Well, actually, Anna, one thing I realized, Anna, do you want to mention the Helsinki stuff coming up?
Yeah, if anyone is going to be in Helsinki, or actually we are having there is a slush, a sort of like web summit in Northern Europe. There is a big event, a startup event, and like 8,000 people are coming to the city. So we are doing 2 meetups during slush. If anybody is in Helsinki, very welcome. Just reach me out in DM. I can send you the link.
It's Anna's home city.
Yeah, I'll publish in Twitter. Anyway, we will publish from Fluence account, and also we will do the live stream. So the link will be published, so you don't have to be actually offline there. Yeah, that's about it on the events so far.
All right, I see Mike really chomping at the bit here. So Mike, it's all yours. Marine, tell us.
Hi guys, can you hear me and see?
Yes.
Great, so I will share my screen. And guys, can you see cursor? Great.
Yes.
So let's start. So as Bernard said, so my name is Mike and I'm doing engineering in Fluence Labs. And today we're going to like talk a lot about Marine, our general purpose WebAssembly runtime that's based on interface types and sharedness and linking scheme. So in particular, the agenda of the section is as follows. So first of all, I will made additional overview of Fluence. So just to point out and for you to have some thoughts about Marine in the Fluence and how it's connected with different Fluence components, with Aqua, Air, with services, and so on. So then we also will be second warm-up section about WebAssembly. So I suppose that not all of you know like a lot about WebAssembly. So this will be just like little warm-up. And then we will talk about Marine, about like a little bit about SDK tools and the connection between air and Marine. So let's start with the first section and let's see again, probably again the slide about Fluence. Probably it will, like it has been shown on one of previous community calls, but it doesn't matter. So actually, like Fluence from one point of view could be considered as a network of services. Yes, that could be composed, and services that expose some functions with help of WebAssembly interface types. They expose it to the network, and then this function could be used to like make some big and distributed function, if you could say such a thing. And also the services could be both stateful or stateless. By statefulness here, I meant that they could save their state on hard drive, or for example in some databases, or so on. For example, on the slide you can see like three services. One of them called relay, but actually there are no any difference between between nodes. They could be both like relays or just exposed services. It doesn't matter. So it's like P2P network with some DHT, academia to be precise. And on this, like on one of the services, you could see that it connected with three different services. And these services aren't compiled to WebAssembly. They just general services. For example, IPFS, some major databases like MongoDB, MariaDB, and so on. So there is some like gateway to connect to third-party services, and also like our services they compile to WebAssembly, and this talk will also lie like between WebAssembly interface types and how it could be executed on a node. And also probably you remember the slide, so I just want you to warm up. So here you could see our language stack, and like the most important thing here is that like Aqua compiled to air, and then this air executed inside Aqua VM that it's compiled into WebAssembly and run through our runtime, like called Marine. Also this Aqua VM could be run into a browser, and now like we are working on a way to like compile just to like allow modules compiled with Marine SDK run into browser natively without Wasm binging. So it's on the way. And also the slide probably you have seen on previous community calls. Here you can see like some slice of our network, and like this network consists of nodes and the clients. These clients here browsers, and all nodes uses Marine to run Aqua VM, yes, and to run services. So this is a place of Marine and connection with all our tools, our sets, our language, and so on. So just runtime that runs everything on a node. So let's dive a bit into WebAssembly, and I personally very like this slide. So the slide was taken from Ben Smith's talk that was on CPPCon 2019. And here you could see like directed graph, and moving from left to right, you could construct your own definition of what is WebAssembly. And I ended with this one. And so WebAssembly is just a standard of stack-based virtual machine. And probably for other slides, the most important topic here is that WebAssembly has only primitive types. By primitive types here, I mean that they're only integers, basically integers and floating points. There are no any complex types like arrays, strings, records, and so on. So they just this 4 or 5 types depending on the version. So on the slide you could see like a big blue box that represents WebAssembly module, And actually, module is a central pillar of WebAssembly, just a cornerstone. And the module contains everything that module is just a piece of code that could be distributed. So could be considered as a program or a library or something like that. Modules have imports and exports, and the important thing here is that WebAssembly code from a module can't access like operation system services. For example, can't access hard drive or memory or something like that without imports. So WebAssembly could just use import to access operation system services. Without imports, you could be sure that WebAssembly code can't access anything except like code inside only one module. Yes, and just so WebAssembly provides you like a way to sandbox code by design. So it's one of the important things for Fluence network, and that's why we are decided to use like WebAssembly at the very beginning. And like expert could be used as a API of this module. Yes, you could consider this as functions that could be called from a host, from like external world, and the functions that the module exposes to the external world. Like the other gem from the WebAssembly world is WASI. So WASI stands for WebAssembly System Interface. It's a standard. So like from the role point of view, it could be considered as a standard for imports. And basically here you can see like this complex scheme, how WebAssembly is constructed from different libraries. For our purpose, it's important that there are about 60 imports that looks like POSIX functions, yes, like general POSIX function from operation system. And if runtime like implement all of these functions, that it could run all modules that compiled with WASI. Yes, it's very handy. So for example, Marine supports WASI, and every module that compiles WASI from different languages. On the side, you can see modules compiled from Rust, so just Hello World, and from C++. And like it turned out that imports in the result will be the same. So, and if like runtime, host, or something, so whatever you call it, if it supports this this import, it could run every module that compiled with WASI. It's just a way to make your system or environment heterogeneous. So, and the last slide in the section is slide about interface types. As I said at the very beginning, WebAssembly supports only basic types, only integers and floating points. And WebAssembly consists of proposals. And one of the most important proposals is called interface types. These proposals brings to the WebAssembly ecosystem like interface types. Yes, interface types here could be considered as a wrapper for. So, for example, imagine that we have like a module. I will call it role WebAssembly module. It's this like it is the center of the slide, and this module could be wrapped with so-called adapted module. And by wrapping here, I mean that every imports and every exports in this module that like could operate only with role types could be wrapped with corresponding imports and exports from the adapted module that could operate with some complex types like array, strings, records, and so on. So, and interface types is basically about lifting and lowering types. Yes, for example, if you code exports with some arrays, some complex types, then you need to lower them and place somehow into the module memory, and only after that call corresponding export. And the same for imports, but for imports you need to lifting them. Yes, you need just to lift them from like raw state from the WebAssembly memory just to external world. So that's it. So interface types is very important proposal, but not so many runtime support them. As far as I know, Wasm time supports like a part of interface types. They developed so-called VIX, like extension, that is extension of WIT, that is intended for WASI. And Marine is like our runtime that support interface types, both with linking, with module linking, that we will talk on the next slides. So let's see what is linking and what is the like Marine runtime from a service perspective of view. So Fluence service, as it was said on Valeri's talk and Valeri's workshop. So Fluence service is just a group of modules that link together by shared nothing linking scheme. And so here it's written that it's with help of interface types, but basically shared nothing linking scheme can't be achieved without interface types at all. So interface types is just it's just a gate that allow you to implement this type of linking. The second type of linking is shared everything. So the difference here is probably obvious. One of the so the difference here is just what which parts of modules are exposed to other modules. For example, in shared nothing linking scheme, only imports and exports are exposed to other modules, and all other state, for example, memory, table, globals, and so on, they're private and they're encapsulated inside module. And in shared everything, so it's opposite stations, opposite. So everything is exported, so memory, tables, globals, and so on. Not only exports and imports. So on here you can see like a scheme where there are three services. One of them called facade, the second SQLite, and third one some authentication module. Doesn't matter which exactly. And these modules are composed together and they form service. So this one is service in our vocabulary, and actually like modules could be of three types. The first one is facade module. So this type of modules could be only could present only once into a service because it exposes API of entire service. Second one is pure module. They just implement some business logic and they can't access to file system and co-external binaries. And effector modules can do anything. Yes, they can access file system, they can call external binaries, and so on. So the goal of this distinguish is just provide, like in the future, just provide some system when people could, so people who run Fluence Node could just, they could just say which module they could run. For example, by reputation. So it's always safely to run pure modules because they can't access file system because WebAssembly is sandboxed by design. Yes, but probably it's not always safe to run effector modules. And then in the future, probably we will have some reputation system or some review system, and such effector modules could they just need to be checked, and people want to we'll have a ability to just say which modules they could run on their runtime on their nodes and which not. Okay, and so the slide is example of our service configuration. But on the previous community call, we have a great workshop that was devoted to developing Euro download services. And here you can see images of config file from previous workshop. It just as I remember. So Here you could see like service that composed of 3 modules. They're defined in some file. They have different settings. Probably like one of the most important and interesting, this one is setting for WASI. Here you can see that these modules, they have only one directory that it could access, and like nothing more, just sites. And for this module, you could see that it's our gateway or our interface to code mounted binary. They just code through CLI, because now WASI doesn't support Unix sockets at all, and that's why the most easiest way to call external binaries is just through CLI, and this scheme we are using. And for example, if anyone seen our curl adapter, it uses curl binary from a system that is mapped to this binary on a file system. Okay, and from also service perspective of view, Marine could be considered as this. As Marine could load several services that consist of several modules. Only factor modules could access operation system called mounted binary and so on. Services are completely isolated. They have their own, for example, modules from one service could call only modules from this service and can't call modules from different service. And except the interpreter. The interpreter is also a module that also loaded into Marine, but in our interpreter we have special instruction called call, and this call could call facade modules from any service that loaded into Marine at the moment of execution. Okay, and let's dig a bit into the Marine architecture. So Marine has a layered architecture. It has 3 layers, and it's allow Marine to fit different purposes. For example, to run services and to run Aqua VM as our interpreter. Basically, Marine could be used in scenarios such as entity component systems. So this pattern is widely used in computer games or some plugin system and something like that, because, for example, plugin here could be just a WebAssembly module or WebAssembly code, and it's really it's real use case for such system. And starting from ground on a very low level, we have so-called engine that has such API. So here are some obvious function, so you could call module by module name, function name, and arguments. And here, please note on IValue, so we will cover this IValue later. Also, you could load and unload modules, and in config, you could specify all settings that you previously seen on a slide that was devoted to service settings. Also, you could obtain interface of module, so all functions that it exported and imports that it has, and also obtain its WASI state. The second layer, it's called FAS, but basically it's called FAS only because we haven't got better idea at the moment of developing. So it's just a second layer. It suits to work with configs, to parse some JSON. So actually, it mapping IValues to JSON and vice versa. It contains a lot of constructors and a lot of to support several variants of Marine creation. It defines a handy host import that we will also see on the next slides. And here you could see IValue that we have seen. This IValue is just basically enum that's contains all types that we are supported now. So we supported records, arrays, byte arrays, strings. So byte arrays here is just to is like designed to like for better performance, just specialization of array and all basic types that's supported in Rust. And here you could see host closures. These host closures, they like allow you to use IValues. So here you could define a function that like could be called from a host, from a like external world, or from Marine, could consider it as like in any variants. And this function receives some arguments that from a module and returns some result. And please note here that like in every place here we use IValue, and it has a big difference with other runtimes, because usually in most of the runtimes that I have seen, you need to solve this problem by yourself. So the problem for lowering and lifting values from WebAssembly memory, because for example, like WebAssembly like supports only row types, and to pass string, you just need to like lower it like by hand. It's just to thinking about how to place into memory, and then in a on a like a Wasm, just how to like lift it from a memory and so on. So just a lot of work, and here it's solved for you. So let's see some example host closures. Here you can see like example that call external binaries that we have seen in the server's configuration. So remember curl. So and here you can see how it could be like constructed. So in my opinion, like it's easy as possible. So you could just receive like this enum with all types and code so functions that like do all job of calling external services. It doesn't important for this example, and then just convert result. Here result is a structure, and by our API call to interface value, you just convert it back to IValue and pass it to a module. So module will call this closure and obtain such a result. And just to like make it provide the Marine information about types and about some linking that like some linking information that runtime must know to link your host expert to some module import. So you just should fill these several fields, just specifying argument types and output types. So, and basically that it, just an example of a closure. So again, if you consider different runtimes, you could see that there are a lot of code of lifting and lowering values that you should write for yourself. Okay, let's move on to the Marine SDK tools. So actually on previous community call, we have a great workshop about SDK. So I will just consider several examples. So here you can see like how Fluence Hello world could be constructed. Yes, just 6 lines of code with help of the procedure macro Marine. And also like more complex examples also are supported. For example, you could use imports. So it's imports on the like how it could be written on Rust. And in the 6 imports, you could use some structures, vector of structures, and return also some like vector of structures and structures itself. Also, you could pass them by link, not by value. So it's looks like vanilla Rust code. Also, we have a second macro called Marine test. Probably we didn't cover it all on a previous workshop or made it very briefly. So, and here is an example of how it could look like for greeting service. So remember, so this greeting service or greeting module, yes, so service could be composed from one module. And like if you have only one function We want to test it, and this function just receive string and return string. And for example, imagine that we want to pass empty string and up like and then the check that everything works fine. So just only 5 lines that you need to write. So just provide marine test with like places where modules are located in your file system and where configuration file for your service that here consists only from one module. So and basically that's it. Also, this code can't compile to WebAssembly and like doesn't run from like inside WebAssembly. This code is run as a Rust code on the host side, and also it's distinguished from other test pattern from different runtimes. And here the benefit of such approach is that such approach provides you a way to test more like as closest to the as it run in the wild as possible, because it's for example if you compile to WebAssembly, then the result could subtle different. So basically we have the second version of marine test that you could test several services. For that you just should use the same macro but provide services like in a row and write code from this. So here process data, my process data here will be run export function from a service from its facade module. So basically that's it about testing. And let's dig into details how interface types works and how multi-module calls under the hood. So imagine that you have URL download service that consists of 3 modules, and for each of these modules there will be Wasm instance. Yes, we use Wasm under the hood, and for each import and for each export there will be dedicated interpreter. It's real interpreters that will interpret interface types instructions. And imagine that we want to call function called curl from module curl from facade module finally. And to do all this there will be some interface types instructions that should be called. So here you could see a prologue of import adapter for this import in the facade module. So this these several instructions, they are intended to lift string from a raw facade memory and then just call this export adapter. And after that here you could see that the purpose of this several instruction in the prologue of export adapter is just to lower memory to curl service. Yes, for example, here we just obtain string size, then call with this size export function called allocate, just allocate memory inside this module, and then we push back. So this arget just push to instructions stack, just push string again, and this instruction that called over memory uses memory that provided by allocate in a string that should be on a stack at the moment to lower string into curl memory. Yes, and finally we call real WebAssembly function, and this function I called raw WebAssembly function. Yes, because we lower memory, and lower memory provides 2 values on the stack, pointer and size, and with these 2 values we call real function from a curl service. Finally, after that we need to pass result back to the facade module, and for that we lift memory back the result string. yes, memory of result string, and pass them back to import adapter of this module, facade module, and then we need to lower it again, lower for facade module. So this basically scheme. We just lift memory from facade modules and pass it to export adapter of Kuro module, lower it to call row function from Kuro module, then lift it back and provide it like in a lifted form to Kuro import this like interpreter, and then it will lower it again, and then the execution of functions that call to this Kuro will continue with the result. So probably you could consider that it's a bit slow, and because there are a lot of lifting, lowering, and so on. But here you could see example of how fast is Redis loading and calling function. So basically, Redis instantiation takes about 300 or 400 milliseconds. So by instantiation here, instantiation includes both compilation stage and instantiation of exports and imports in Redis. And then here you could see that like the first calling the function at first in Redis takes about 3 milliseconds, and a second, and all following times it will take about 70 microseconds. This is like this fish, and the fish for some reason can't print mu. Yes, but believe me, it's mu, it's microseconds. So basically it's all that I wanted to talk about. And today we have covered several topics, the most important marine and Rust SDK, and also I considered the air and Aqua a bit. And all this project is so they're open source. You could find by this link. And also, I think you know about how to obtain project updates, but probably for some person who will see this on YouTube, probably I need to speak it back again. So actually, we have a Twitter, we have a newsletter on the Fluence network, our main site, and we have a Telegram channel with some technical updates. And also, if you have any questions, please write to me, or file issues in all these repositories. So we're very open for your questions, for your thoughts about this one. So basically, that's it. Thank you very much. So I'm waiting for your questions.
All right, thanks, Mike. It was awesome. Anybody have any questions? Chat or unmute your mic. All right, while we're waiting for the masses to formulate their thoughts and put them in chat, Mike, I got a question for you. How does that the load on Redis, how does that compare to cold starts in Amazon Lambda, for example, or Cloudflare Workers?
Oh, it's a difficult question, and to be honest, probably I can't provide your some info because in some sites, because I haven't tried Amazon Lambda, Redis, or SQLite. Probably we need to do that. So yes, probably it's a good. I know it's a good topic for research.
All right, I didn't mean to throw you a difficult one. I kind of thought it's okay. Anybody else? All right, so second question then regarding the loading of the modules. Once they're loaded, are they stay hot basically, or is there some optimization happening on the?
Sorry, could you please repeat hot?
Once you load the module, like the Redis module, for example, does it stay hot, or Does it get kicked out of memory at some point?
So basically now it's it's always in terms hard that it's will always will be in the memory of Marine, as there are no any way to just unload memory to file system, but probably so actually we discussed it previously, but haven't got time to implement that. Probably it will be a good good addition to Marine.
Okay. Anybody else? So where do you see WebAssembly going? Like, where do you see this whole the backend WebAssembly going in terms of portability and reuse?
I think that actually there is a niche that probably like Docker in. I mean that Docker suits for different purposes, but probably actually there could be some that by Mozilla or by code aliens that called nanoprocess, some process that actually it doesn't need like entire Docker environment, some Docker settings and so on, because it's not so cheap for operation system, especially if you run like really a lot of Dockers. And for such process or a group of processes, in my opinion, it's better to use WebAssembly instead of like wrapping it into Docker, because like WebAssembly will provide you sandbox first of all, and then it will much cheaper for operation system than like wrapping it with Docker. And also this nanoprocess could be extended to some browser cases, because you know that there are a lot of attacks and a lot of vulnerability when some malicious person just upload to some JavaScript packets, some backdoors or something like that, and by starting it by compiling this JavaScript into WebAssembly and using pattern that I called entity component system, so just wrapping all library into WebAssembly, it will guarantee you safety from such attacks, because it will be sandboxed.
So okay, so if anybody has any questions, because I have more questions.
I can try.
Okay, go ahead.
So if certain blockchains will in the future or now have a Wasm compatible runtime thing where the smart contracts are running, how do you envision then communication between that and Fluence?
Between blockchains and Fluence. Dmitry, could you do you want to ask the question?
Well, why not? There is a I don't exist. Hello. Generally speaking, it doesn't matter what exists inside an external blockchain or a service or whatever, especially if it's a blockchain from the integration point of view. Anyway, it's external. So you need to make an effector as a dedicated WebAssembly module within this Marine ecosystem. That's speaking about interoperability. And another question is whether this WebAssembly written for the blockchain will run the same way in Fluence. That's an open question, because Marine is almost the only runtime that supports interface types and if that blockchain will take Marine as runtime of choice for WebAssembly, then it will also support interface types. We'll provide this information within the WebAssembly package. So you'll be able to get this WebAssembly from the blockchain, prepared for the blockchain, and run as a pure module, probably pure on Fluence. And if you want to use the module that you have compiled for Fluence for Marine with this Marine macro and then interface types and so on, probably it will work on a chain out of the box, because probably you will still have this low-level API available, but it's not so useful. Not so, like, probably you will want to compile it again for that blockchain. Does it make sense?
Well, yeah, I was thinking about this question for the last few minutes, and I realized it was sort of a stupid question, but I wanted to ask it anyway, because basically the problem is that the blockchain is running over like thousands of computers, so the call will come 1,000 times. So it's like, anyway, sorry. I asked my question.
But probably like having some bridges to different blockchains will be a good idea. These bridges will provide you like information from blockchain, and you could compute them and I know, do the different things with blockchain data. So as I understand, in the blockchain world now is the era of bridges between different ecosystems.
Yeah, okay, but which wouldn't be so hard to do with Fluence in a very slow way, because you can pull the one and you can pull the other. But that's probably way too slow for what the people want to achieve with bridges.
Well, you can pull, for example, with that's not a topic of the triggers for Aqua functions. So currently the trigger is either time or the send request. But later we want to extend the event loop within the Fluence peer, the Fluence node, and you'll be able to register the new event triggers, and probably that could be also this event from the external chain to remove this latency as it's unnecessary. So I think that Fluence either fits or will fit to make bridges between different subsystems. But making a bridge a good one is a hard task. So each one should be considered on its own.
No, I mean, what I'm trying to do with the things I'm thinking of is like making these bridges, but it's for really slow data. It's for data that you want to keep around, like whatever, election data and everything. It's not for trading. But if you think, who knows?
Okay, well, let me take the other branch of Mike's last statement. So Docker, if I remember correctly, Solomon Hykes, who created Docker, he basically said when he saw WASI that if that had existed, they wouldn't have had to invent Docker. So going back to where you came from, Mike, from that position, how do you do you think that with Marine and Aqua you could effectively replace a lot of Docker installs? Is that what you were saying?
Yes, I just I just had it in my mind when I talked about it. So actually with Marine, I believe that probably in the future you could use it like instead of Dockers in several kind of tasks, just to run just run small processes or processes that really they just need only isolation and just need sandboxing and not entire Docker Docker system. Regarding Marine, or sorry, regarding Aqua, I think that like Aqua with Marine would increase, so would increase area of area of problems that could be solved by Marine. But regarding Docker, probably I would say that Marine could be like be a replacer of Docker in several kind of tasks.
Okay, because Solomon, he sort of went on then to say that basically, well, Wasm wouldn't replace Docker today, but it probably could become the most popular payload of Docker compared to anything else.
I think that what WebAssembly won't replace Docker at all. I mean entire Docker. So my main point is that there are a fraction of tasks that now are done with Docker that could be done with some runtimes like Marine. Not all tasks that suits for Docker, because for example, if you want some, if you want some environment when you have your databases, your for example, I don't know which one, Marine, for example, like MongoDB, that couldn't be compiled to WebAssembly now, and probably in the nearest future also. And some other services that also can be compiled to WebAssembly. So then, of course, so it's better to use Docker. But like I believe that there is a fraction of tasks that Wasm suits better.
Okay, well, we'll have to work on that because that's a really interesting area.
Yes, I believe.
I will not drag anybody else with me and Mike further down that rabbit hole. If anybody has any questions, now is the time. Otherwise, we'll call it a day.
I have one question. Mike, do you have any plans or any features that you want to implement and deliver with Marine in the following months? Like any kind of roadmap or highlights?
So as I said, we have like ongoing project that we're working on, and this project is intended to allow you to run binaries, WebAssembly binaries compiled with Marine, not with Wasm binding. Is it now in a browser? So, for example, in the future, it will allow you to run Aqua VM that will be same for browser and for node side. Because now it's a subtle difference, like basically difference in the export, how export works. It will allow you to also run services in your client, in your browser. So I think that Marine Web is a good step and a huge step for Marine at all.
So it means that Fluence services will be universal, right? Yes. You just can use the same in the web browser, and it will also support interface types with these structures, or
and also you could run it in a Node.js and anything else that is uses browser engines.
I think it's cool.
Very cool. Let's do it. All right. Well, on that uplifting note, another community call draws to a close. Thank you, everybody, and we'll see you in 2 weeks. Bye-bye.
Thank you.
Thank you.
Thank you, Mike.
Thank you.
Thank you, Mike. It was
Bye-bye.
awesome.